Okay, so this is the next topic that we're doing. It's 6.5. This is video 121, and factoring with binomials. And when I say binomials, I really mean a linear binomial, but we don't want to get too deep into that. We'll just work on this here. So I want you to take a close look at what I've wrote on the board here. This is a trinomial, a quadratic trinomial. You can't factor anything out. The three terms don't share the same thing. Sure, x squared and 7x share the x, but it has to be all three. 7 and 12 are co-prime along with 1, so we're good. And also, let's say this right away, there's a 1 here. I'm going to leave it out because the weaker students get confused. But there's a 1 there. You keep that in the back of your mind. That makes a big difference here. Now, I'm going from here to here. And the question is, what did I do? Why did I choose those two numbers? And that's the section of this, that's what we're going to talk about in this lecture. Okay? However, without saying why I chose 3 and 4, no one in their right mind would deny that this is different from that. Agreed? Just do it in your head. 3x and 4x are like terms. So I just rewrote this. Instead of 3 terms, I wrote 4 terms. Why? If you look at the next step, I want to factor. So we know how to factor this. The x squared and the x share the x. There we go, co-prime. And the 4 and the 12 share the 4. And what's left over? The leftovers there are x and 3. The leftovers are the same. There are 2 of them. So that's going to mean that we could go from the next step. We factored the x and the 4 with a 3x. So when I write them together, this is factored by this. The x and the 3x. The 4 is factored by the same thing, and you can rewrite it 3x plus 4x. That is 3 plus x plus 3 factors x plus 4. Foil it, and you'll get the same idea. So notice that I went from here to here. I went in a big circle. By the way, this will be the answer for the weaker students. Okay? This is factored by this. Now, not everybody's factorable. Not all trinomials can be factored. Just like a lot of numbers can't be put into prime factorization. Lots of them. But we won't get into that now. We'll just say that we were able to go from here to here. And let's do something now and immediately address how I came up with 3 and 4. Now that's important. So why didn't I use 5 and 2? Doesn't 5 plus 2 equal 7? Or 1 and 6, doesn't 1 plus 6 equal x? Because when you break these numbers up, their product, that is, when you multiply them together, it has to equal the last term. So you say, oh, okay, this times this must equal this, and this plus this has to equal this. 2 conditions, okay? So you say, oh, well, their product has to equal 12. But what numbers equal 12 with a dual product? Well, 1 times 12. 2 times 6. And finally, the 12 here, the 3 times the 4. Well, when I add this up, I get 13. When I add this plus this. When I add this up, I get 8. And when I add this up, I get 7. So you might think of it as a bit of a key. You see, I broke it up this way because 3 plus 4 equals 7. And at the same time, 3 times 4 equals 12. That means it's factorable. When you can do that, it's factorable. Then I factored when I broke it up into 2 distinct parts with 4 terms. The x was connected by the 3 plus x. The 4 was connected by the x plus 3. Sorry, x plus 3, x plus 3. And when I put them together, I get x plus 3 times x plus 4, which is properly factored. Okay? If I just looked at it this way and say, well, what 2 numbers equal 12 and add up to 7, then I'd use 1 times 12 is 12, but they add up to 13. 2 times 6 equals 12, but the middle terms add up to 8. So only 3 times 4, or 4 times 3 work. And so now I'm going to show you in math, you can always do it the other way. And I don't want you to think that this is too easy, because we always have the 1 here. We'll go over that in a second. Now I'm going to do it a different way, and then I'm going to check using the division that we learned. Okay? So that's how I came up with 3 plus 4. I broke this up. It's the same thing. I explained to you why I didn't choose 5 plus 2, because 5 times 2 equals 10, not 12. I explained to you why I didn't use 1 plus 6, because 1 times 6 equals 6. What I had to do was write this 3 terms into 4 terms so I could separate them, okay? That would be called factoring by grouping, by the way. That has a name. And then put them together and come up with the answer. This turns out to be a very important skill in high school. Okay, freshmen? So now I'm going to direct the camera over this way. And I'm going to rewrite it again. So hopefully I explained why we came up with 12. Everybody needs practice, because obviously there are lots of trinomials out there. Some are factorable, some are not. And the whole purpose of this is to get in practice with things you can factor. But let's just go back and say, oh, okay, well, why did you write the 3 first and 4 second? And I'm here to show you that it doesn't make a difference. If you're factorable, you're factorable. It's really that true. So now factor grouping them here and grouping them here. X squared plus 4x is x plus 4. And now it works if I can get x plus 4 here. That's how the whole deal is going to work. Well, 3 times x is 3x. 3 times 4. And we were very confident, of course, because we did it the other way. Okay? And so x plus 3, in any order, by the way, times x plus 4 is the correct answer, going from here to here. But again, the commutative property of multiplication guarantees you that when you switch the order of polynomials and you multiply them, you get the same answer. I can FOIL this and get the same answer, but I'm going to do it a different way. And I'm going to divide to get the check. So I'm going to divide x plus 4 into x squared plus 7x plus 12. And come on, guys, you're paying attention. What do you think I'm going to get? Well, just like with the numbers, the same thing works. Okay? There's the x, matching the x squared. There's the 4x. There's the negative. There's the negative. There's the 3x, because there are more n's than p's. And there's the 12 that I brought down. And x goes into 3x 3 times. And 3 times 4 is 12. There's the match. And there's the check that we could do certainly different ways. So the factorization of this, shown 2 ways, is this. And that's the kernel idea of what you'll be doing, although the numbers will get more complicated. Not bigger. They never do that in Regents math. It will just be the work would be a little bit more complicated and challenging for you. Okay? So this is the beginning of where we're going, and I chose the simplest example that I could imagine, and I'll follow these up doing this kind of math. And I want to repeat that it was so easy because in front of our original problem, here, let me lift this up, is a 1. And I'll go into that later because the rule says that you multiply the coefficient here by the last term. And 1 times 12 is 1. So certain kinds of quadratics are very easy to factor. And if you think about it, if you just chose 3 and 4 as factors and put them here, they're both positive, you have the answer right away, and you can forget and ignore this intermediate step. But we'll find out that I'm teaching it this way for a reason. This step is not to be ignored. Okay, we'll leave it like that, and we'll come back with a follow-up video.